Right. So I'm going to talk about knowledge graph applications for cultural collections. And I'm going to talk about the promises of this technology, the issues that we encounter, and the reality, how we put those into practice. So what is the core promise of linked open data? Institutions like museums, libraries, and archives all catalog their holdings within their own databases. In addition, they use domain-specific metadata standards to catalog their data, and they are not necessarily compatible with each other. So cultural data ends up in individual silos held by their respective institutions. And linked data could bridge these silos by identifying and connecting individual pieces of data within those databases using URIs. If you can somehow agree on using the same URIs for identifying the same things, linked data could also enable us to discover resources on a certain topic by querying multiple databases with the URI, for example, for Lisa Gherardini. Without having to know the structure or cataloging standards of individual cultural collection, this could bring up database entries on the Mona Lisa in a museum collection or references on Leonardo da Vinci in a library catalog. Linked data, or more fashionable knowledge graphs, also allow to shift focus, and that is often required when doing research. Cultural data is usually cataloged from a perspective of the individual work, so work that has a title, a technique, an artist, or a subject. In a linked data environment, it's possible, for example, to shift from individual work to a network, so to focus on individual artifacts and hypothesize on the relationship between them. How can we fulfill those promises? I mentioned how we want to link data with URIs. That sounds simple enough, but which URIs do we actually choose? And here we have two main concerns. We have to describe the meaning of the data and the shape of the data, and we have to identify individual entities. So on the one hand, it's about shared data models, and on the other hand, about shared reference data. And we tackle both in our applications. The first one we address in our SARI reference data models, and this is really for enabling shared description of cultural data. They are available for a number of entities that we usually find in cultural data sets. The models themselves are based on CDOC CRM and its extensions. For example, we use FRBROO for biographic data, or CRM-DIGH for a description of digital provenance data. And the models themselves are also compatible with linked art, so we don't create competing models there, but models that maybe also cover the use cases that are specifically not addressed by linked art. And on the website, we find the documentation as well as individual modeling examples. For example, here we see how we model birth and death dates and places for an individual person. The second issue, the one of identification of entities, we facilitate through the SARI reference data service. And this provides kind of single access points to multiple reference data sets. On the one hand, via kind of web-based front end, we see here in the screenshot. On the other hand, via lookup API. And this API implements the draft of the W3C reconciliation API. It means it can be used with applications that implement this, for example, OpenRefine. And what we also support is adding new reference data. And this is, for example, in a scenario where we discover entities in your archive, in your collections that do not exist yet in any other reference data. You can contribute those, but you can also contribute data that links to existing entities. And this is then a mechanism that we use to discover the same entities across collections. So the linked data promise is that you can go from one and it links to everything else. In reality, it's often that individual collections and data and reference data services only link to specific ones. So, for example, many link to Wikidata, but not to ULAN. And what we do in RDS, in the reference data service, is we make use of those links to establish additional links between entities that not directly link to each other. So this is one fulfillment of the linked data promise, that data that links to the same entities can be discovered as a whole. Now, does this actually work? Following the paradigm of eat your own dog food, we also use our own services and models. And in particular, in this project, which is still in development, about images of Switzerland. And it is already public. We can always share the link and the slides. And it is a knowledge graph of historical images of Switzerland, which originate from 3 different cultural collections: the Central Library of Zurich, the National Library of Switzerland, and the Familie Fehlmann Foundation. And we receive this data in a variety of formats. So we have mark XML, custom XML formats, as well as Excel sheets. So it's both in terms of how the data is structured, as well as the data types itself. There's a huge variety. We then use the SARI reference data model to combine these individual pieces of fields that we have defined there to a model that represents the data incoming from the collections. And this has allowed us to harmonize the source data, but also to do so in a way that retains the detail of the original data. We use the reference data service to align entities, in particular persons, places, events, but also keywords. And when we linked to existing resources, mostly the G&D, which covers a lot of our use cases, as well as Wikidata. So this linking allowed us to align entities that appear across collections. For example, here, Godefroy Engelmann, which has works in both the collection of the Central Library as well as the Swiss National Library. And this is crucial because often, persons don't have the same names, or persons have the same names, but actually different persons. And this happens a lot when we have painters where the son carries the same name as the father, and it's sometimes difficult to discriminate between them. The actual transformation from the input files to RDF we did using a mapping file created by X3ML mapping tool. Some of you might be familiar with it, some of you not, but it's findable. And we publish it all on a research platform, which is built based on the MetaFacts open source platform. And the platform itself is accessible under this URL. And you will also find most parts of the pipeline in this PSO data pipeline repository. So although this is not yet finished in public, we kind of went the publish first approach, put everything online as early as possible, with the idea that we also discover issues and problems early on, but maybe also get early feedback by users who explore these collections. And that's it. Thank you.